Good morning. I am Anitha, Assistant Professor in the Department of Artificial Intelligence and Data Science. Now I am going to discuss about the topic frequent items at mining. First, coming to what is frequent items at mining. That is an item set that is contains a set of items, and I discuss about the relationship or association between the data present in the item sets. For example, we purchased computer, printers, Microsoft Office software. That is three item set, and then milk, bread is two item set. Similarly, set of k items is called k item set. Frequent patterns are patterns that appear frequently in a data set. Patterns may be item sets, subsequences, or substructures. For example, a set of items such as milk or bread that appears together in a transaction data set, also called frequent item set. Frequent item set mining leads to the discovery of association and correlation among items in large transactions or relational data sets. This helps in many business decision-making processes like catalogs, designs, and customer shopping behavior analysis, etc. Next, coming to market basket analysis, this is one of the best example for association rules and also frequent item set mining. This process analyzes customer buying habits by finding association between different items that customer places in their shopping baskets. Market basket analysis. This is an example of frequent item set mining. This process analyzes customer buying habits by finding association between the two items or different items. Next, retailers can use the results by placing the items that are frequently purchased together in proximity to further encourage the combined sales of each items. In our example, milk and bread is frequent, so it can be kept in proximity. Other example is if customer who purchases computer also tend to buy printers at the same time, then placing the hardware displays close to the printer may increase the sale of both the items. Next is some of the basic concept in frequent pattern mining is the technique of frequent pattern mining is built upon a number of fundamental items. The analysis is based on transaction basis, that is databases, which includes records or transactions that represent collections of objects, items. Inside these transactions are grouped together as item sets. First, collect the data sets from the large sets of transactional databases. That is the raw data. Then scan the frequent items in databases, update the databases, and construct the CFP tree by using constraints. Call the CFP growth frequent items and then constraints frequent patterns. Next is some of the techniques that are used in the frequent pattern mining is three algorithms. One is a priori algorithms, FP growth algorithms, LCAT algorithms. Next, coming to a priori algorithm, one of the most popular method, the a priori algorithm used a step-by-step process to find frequent item sets. It starts by creating candidate item sets of length 1, determining support and eliminating any that fall below the predetermined cutoff. The method then joins the frequent item sets from the previous phase to produce bigger item sets repeatedly. Once no more common item sets can be located, the procedure is repeated. The a priori approach is commonly used because of its efficiency and simplicity, but because it requires numerous databases scans for big data sets, it can be computationally inefficient. Next, coming to FP growth algorithm, that is frequent pattern growth algorithm. A different strategy for frequent pattern mining is provided by the FP growth algorithm. It creates a small data structure known as the FP tree that effectively describes the data sets without creating candidate item sets. The FP growth algorithm constructs the FP tree recursively and then directly mines frequent item sets for it. FP growth can be much quicker than a priori by skipping the constructions of candidate item sets, which lowers the number of runs over the data sets. It is very helpful for sparse and huge data sets. Next, coming to ECLAT algorithm, that is equivalence class clustering and bottom-up lattice transversal, are the acronym for the ECLAT algorithm. As well, like the frequent pattern mining methods, to explore the item sets, LAT is using a depth frequent search approach concentrating on the representations of vertical data formats. Transactional identifiers are effectively used by ECLAT to locate intersections between item sets. These techniques is renowned for its ease of use and little memory requirements, making it appropriate for mining frequent item sets in vertical databases.